Okay, you have a CD that has a diameter that is 110 millimeters. Well, if the diameter is 110 millimeters, for our formula, we're going to need the radius, which is that distance there, and that would be half of the 110, so that would be 55 millimeters. But our little problem over here, our little answer says the linear speed of reading along the outer edge of the disk is blank meters per second. These are in millimeters. So I have to remember that 1 meter is 1,000 millimeters. So if you take 55 millimeters and multiply it by the conversion of 1 meter over 1,000 millimeters, that way the millimeters can't cross cancel. So you're ultimately just going to be taking the 55 and dividing it by the 1,000. So that'll put it into meters. So I end up getting 0.055 meters. Okay, that takes care of that issue. When playing audio, the angular speed varies to keep linear speed constant where the disc is being read. When reading along the outer edge of the disc, the angular speed is about 180 revolutions per minute. Now, if you've ever played a CD and kind of opened it while it's still spinning, I mean, it's going around. This is the outer edge, and it's going around and around and around and around. It's spinning pretty quickly. But anyway, they're telling me that, okay, the angular speed, that's that W letter, is 180 revolutions per 1 minute. Okay, and that's your angular speed. However, the formula for angular speed, no, that's right, revolutions per minute, we're being asked to find the linear speed. Nope, orange. Find the linear speed. The formula for linear speed is V is equal to S over T, but S is actually R times theta. Okay. S is R, which is our radius, times theta. So I know that right here I'm going to have the 0.055, that's my radius, times my theta. Now theta I've got to figure out. Okay, revolutions, there's 180 revolutions per minute, but one revolution, need another color. How about the yellow? Okay, one revolution is equal to 360 degrees, which is also known as 2 pi. And we're doing 180 revolutions. So theta is actually gonna be 180 times, okay, I don't have much room here, let me fix this, sorry. S is equal to theta, R times theta, just writing these numbers down, and the radius is the 0.055 times theta. Theta is going to be the angle measure. So it's the, oh, I'm not explaining this very well. Your angle measure, when you go 1 revolution, that's 360 degrees, so that's 2 pi, but they're doing it 180 times, so it's going to be 180 times the 2 pi to figure out the angle measure. You know, it's like one of those terminating ones, like you keep going around and around and around, and that ends up being, where's my time? Oh, I'm good. Okay, that ends up being 62,203 point, and then there were some numbers in my calculator. I don't remember what they were, but it filled up a couple of more spots. But when you get that, that is oh, I take that back. That wasn't the right number. My bad. My bad. I didn't write this part down. Let me try that again. 0.055 times 180 times 2 times pi gives me, all right, that gives me 62.20353454, but the units on that, your radius was in millimeters. This is in millimeters, and that's your numerator, which is right here. This number is my numerator here, and then time is supposed to be, oh, the denominator, time is in 1 minute of time. I am really sucking at this tonight. 1 minute of time, but it's supposed to be in seconds. So I have to then take, oh my gosh, I've got millimeters per minute. So I got to multiply that. In 1 minute's time, there are 60 seconds. So I have to take this orange number, which is right here, and divide it by 60. Take the orange number and divide it by 60, and then that's where you'll round to 2 decimal places, and I end up with 1.03, but then the next number is a 6, so I get 4, and now that is in, that's not millimeters, sorry, that was meters. Meters right here. Meters per second, which is what we have here. And I had already gone in here and checked it, and there it is, 1.04 meters per second. Okay, so that is the end of my whatever problem this is. Which problem is this? 6? Problem 6. I don't know if I explained that very well. Somebody let me know if this makes sense or if you're totally confused, and I'll try to do another video.